Hi there, folks. Today we're looking at graphing lines using the slope. And we've looked at slope in a couple different ways. We used our formula. We used change in y over change in x. We used rise over run. For today, when we look at these things in terms of the graph and using the slope to the graph, we're going to focus on that rise over run. And at a more basic level, rise over run is just the visual pattern that we see to get from one point to the next on our graph. When we graphed these things using points, we could see that there was a pattern to get from one point to the next, and we could use that pattern to plot more points. Well, now we're going to look at it from the perspective of plotting a single point and then saying, okay, the slope is the pattern. It's rise over run, so now I can use that to plot all the rest of my points, okay? There are two formats of the equation that we're going to look at for plotting a point and then using the slope to graph. The first is called point-slope form. And point-slope form gives us two things. It gives us a point that's on the line, and it gives us the slope of the line. And that's why it's called point-slope form. So it's y minus y sub 1 equals m times x minus x sub 1, where m is the slope. That's the pattern we're going to use, that rise over run. And then x sub 1, y sub 1, that's the point that's on the line. So that's giving us an ordered pair. And one of the things you need to notice here is the minus signs that are in the formula. Anytime we have a formula that have minus signs built into it, it's better to think of those as kind of opposite signs. You know, like a negative symbol, we think of it as a negative symbol, but it's an opposite symbol. And when we're talking about numbers, yeah, the opposite of a 4 is a negative 4, all right? Negative kind of refers more to numeric values. That sign is really just telling us the opposite of that thing. So when you see y minus y sub 1, it's saying y, and then it shows us the opposite of the y value. And then m, and then x minus x sub 1, it's x, and then the opposite of the x value. So keep that in mind. Anytime you see a minus sign in the formula, it kind of appears as if we're just doing the opposite of that value. And essentially we are. For example, if we look at something like this guy, see, I've got y minus 2 equals negative 2 times x minus 3. The first thing I want to do is identify the ordered pair. And so when I'm looking at this thing, the ordered pair is x comma y. Well, the x value is located over there with x. So we see x minus 3. But again, because the formula has a minus sign built in, it's x minus a positive 3. So really, it's the opposite of that minus 3. So it's going to be a positive 3 here for the x value, okay? Likewise, over there with the y, it says y minus 2. So the actual y value for my ordered pair is a positive 2. All right? Because there's a minus sign built into the formula, it's like we're doing the opposite. And essentially, it's because it's y minus, and now what I'm left with is a positive 2. X, part of my formula, minus part of my formula, positive 3 is the actual value for the ordered pair. All right, so keep that in mind. The minus sign acts almost like an opposite sign when you're looking at a formula, okay? And then the slope is just what's in the front of the parentheses there. In this case, it's a negative 2, so the slope is negative 2. And again, you can always think of any number as a fraction, so it's negative 2 over 1. It's telling us, hey, the pattern is down 2 over 1. It's rise over run. Negative 2 over 1 means down 2 over 1. So let's plot this thing. I plot the ordered pair, 3, 2. 3, 2 is right here. And now from there, I use the pattern. The pattern is negative 2 over 1. Again, if you think of this guy as rise over run, rise of negative 2 means you go down 2, and then a run of 1 means you go over 1. So it's basically just giving us that pattern. So down 2 over 1, and I can keep it going. Down 2 over 1, down 2 over 1. I really only need 2 points to graph this thing. But again, if I'm freehanding this graph, it helps to have more points to try to make my line straight. And if I continue the pattern going the other way, it would be up 2, back 1, up 2, back 1, which is the same thing as a negative 2. And now I can graph this line. Okay? But we're starting with a point and just using the slope to graph from there. If I look at something like this guy, again, let's identify the point that's on this line. I look over at x and I see x plus 2. So that means my x value is actually the opposite of that. It's a negative 2. I look over at y and see y minus 1. So my y value is the opposite of that. It's a positive 1. And the slope this time is written right there. It's a 1/2. So I plot the point that was given, the negative 2, 1, right here. And now the slope of 1/2 is telling me the pattern, rise over run, is up 1 over 2. The 1 in the numerator tells me to go up 1 because it's positive 1. And the 2 in the denominator tells me to go over 2 because it's a positive 2. So up 1 over 2. And I keep that pattern going, up 1 over 2, up 1 over 2. I could keep the pattern going the other way, just visually look at it and say, okay, I would have to go down 1, back 2. So visually, just make sure you continue that pattern, and now I can graph this. Once again, we only need 2 points to graph this thing. And if you have a straight edge, that's great. If not, plot a couple extra, and now you can do a pretty nice job of drawing a line that's nice and straight, even without the straight edge. Okay? The second format, and this is probably the one we're more familiar with, is slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And of course, b is the y-intercept. We know how to find the y-intercept. You plug a 0 in for x. So think of it like your cover-up method. If you were to plug a 0 in for x right here, you would get y equals b, which would be the ordered pair 0, comma, b. All right? That's why that value at the end is the y-intercept, is because, well, it just so happens that because of that format, if I plug a 0 in for x, y is always going to equal whatever that number is. Okay? And so you could still find your y-intercept the same way we've always found it, by plugging a 0 in for x, okay? And the other thing is, yeah, think of this as an ordered pair. Remember, it's the ordered pair 0, comma, b, all right? So that b value is the y-intercept, okay? For example, if I look at something like this guy, again, just like I did with point slope form, I got to start with the point. I can't jump to the pattern yet, so the slope doesn't help me until I have a starting point. In point slope, it was any point on the line. In slope intercept, it's just a very specific point on the line. So for this one, the y-intercept would be 0, negative 2. And again, you could just plug a 0 in and you'd find out the y equals a negative 1. So it's 0, comma, negative 1. The slope this time is a positive 2. Again, that's like 2 over 1 if you want to think of it that way. And so now I start with the point that's given, so I'm basically in the same boat. 0, negative 1 is right here. And now the pattern is rise is positive 2, run is positive 1, so it's up 2 over 1. And again, that's technically enough to graph, but I'm going to keep that pattern going up 2 over 1. If I keep the pattern going the other way, down 2, back 1. And now I draw the line. And again, I'm drawing it without the use of a straight edge, so I want it to be as accurate as possible. I plot a couple extra points, okay? And I kind of missed a little bit there. Oh, my bad, all right? But we all get the point. If I look at the next one, again, the ordered pair for the y-intercept is 0, 2. It just happens to be this end value because anytime I plug a 0 in for x, that's what I'm left with. So I plug a 0 in for x, I get the 2 out. And now the slope this time is a negative 1/2. And notice that negative is written out front. You could write it with the numerator or denominator. Okay, so I could write it as a negative 1 over 2. It's the same thing. And when I'm talking about rise over run, I have to put that negative with one of them. All right, so it tells me whether to go up or down or left and right. I always stick it with the numerator. It's always easier that way. Create your own consistency there by always doing the same thing. So let's see, 0, 2 is right here. I plot that point just like I've done in the previous examples. And now I use the pattern. The pattern is a rise of negative 1, which means I go down 1, and then a run of 2, so over 2. So down 1 over 2. And I can keep that pattern going. Down 1 over 2, down 1 over 2, down 1 over 2. Or I could keep the pattern going the other way. It would be up 1, back 2. All right. And now I graph this line. All right. But again, using the slope is just the pattern. I start with a point that's on the graph with point slope form. It's any point on the graph, and then I use the pattern to graph the rest of the points. With slope intercept form, it just happens to be the point that is the y-intercept. So I'm still starting with a point. It's just a very specific point now. And then I use the slope, the pattern, to graph the other points. Okay? If I look at this, vertical and horizontal lines, and we already know a little bit about these, and we understand the idea of their slopes. But now we're going to look at their equations so we can use that idea of slope with vertical and horizontal to graph these things. So vertical lines, remember the slope is undefined if we're thinking about it in terms of steepness. All right? They're so steep that I can't measure it anymore. All right? They're always in the format x equals c, or really x equals a number, where c is a constant. So what that's saying is it's always x equals a number. And that seems backwards to students most of the time because a vertical line, we kind of think of it and say, well, the y-axis is the vertical axis, so shouldn't it be y equals? No. X equals gives us a vertical line because the x value stays the same while the y value changes. And think about it, if you start changing the y value, you start moving up and down. If I give you different y values, it's going to make you go higher or lower on the graph, okay? And so the x value stays the same, the line travels up and down because the y value changes, all right? So the x value staying the same creates a vertical line because the y value changes. We can also think of it in terms of the ordered pairs there. Likewise, a horizontal line has a slope of 0, and it's always y equals, all right, some number. And once again, it's the same kind of deal. If the y value stays the same, in other words, the height of this thing doesn't change, the only thing that changes is the x value, which means the graph goes left and right. So it creates this horizontal line, okay? For example, if I look at something like these guys, let's determine if I have a vertical or a horizontal line based on the slope. So if I look at something like this guy, again, I'm going to do the old change in y over change in x. Everybody loves it. So if I look at y, it was a -5. Now it's a +7. Think about that on a number line. From -5 to +7, you have to go up 12 units. And then from 4 to 4 on a number line, you don't have to move, so you move 0 units to get from 4 to 4. And now 12 divided by 0, we can't do that. That's undefined. So if the slope is undefined, what kind of line do I have? Well, I have a vertical line. And we've already done these, but we didn't identify them as vertical or horizontal. We just identified the slope. Now we want to keep making those connections to, okay, what does a slope of undefined mean? Now visually, what does it look like, okay, in terms of that slope? If I look at the next one, same kind of thing. Change in y, it was a 3, and now it's still a 3, so change in y is 0. Change in x, it was a 2, now it's a 6. It's gone up 4. Well, 0 divided by 4 is a 0. So if it has a slope of 0, it means I have a horizontal line. If I look at the next one, same kind of thing. Change in y over change in x. The y value was a -1. It's still a -1 in the next ordered pair, so the y value didn't change. So the change in y is 0. If I look at x, it was a +1. Now it's a -1. So on a number line, think about that. To get from +1 to -1, I have to go down 2. And 0 divided by -2 is still a 0. So this is a horizontal line. And so this is giving me an idea of how to graph these things. And when you look at this, look at which values is changing and which values staying the same. If I look at the next one, change in y was a 3. Now it's a -3. To get from 3 to -3 on a number line, I have to go down 6. Change in x, it was a 2. It's still a 2, so x hasn't changed, so the change is 0. So this is undefined, which means, once again, we have a vertical line. And again, think about that for a moment, okay? We're looking at the slope, but now we're visualizing what this line looks like. And again, when you look at the equation, the format for a vertical line versus a horizontal line, the vertical line was x equals a number. The horizontal line was y equals a number. Look at these examples. Look at the first one. It's a vertical line, and look at the x value. X is a 4 in the first ordered pair and a 4 in the second ordered pair. X equals 4 every time. If you look at the next one, the y value stays the same. Y equals 3 every time, and it's a horizontal line. The next one, y equals -1 every time. So y always equals -1. Y equals -1. It's a horizontal line. And then the last one there, the vertical line, well, look at the x. X is a 2 every time. So when x equals 2, it's a vertical line. And so hopefully you're trying to make that connection between the equation and whether it's vertical or horizontal and how that relates to the ordered pairs and the slope and all of that stuff. And hopefully you're looking at this going, okay, I know what the equation of each of these is. The first one's x equals 4. The next one's y equals 3. Then y equals -1. Then x equals 2. Because that's the value that stays the same in each of these. Okay? For example, if I look at this one, let's use the slope to graph, right? So here we go. We have y equals 2. Well, a y value of 2 is located right here. So there's a y value of 2. That's like a y-intercept of 2. But now think about the slope. If it's y equals 2, it's got to be a horizontal line. The y value has to stay the same. And if it's a horizontal line, the slope is 0. And I graph the slope as 0. So I draw a horizontal line. And again, think about the ordered pairs on that line. The first one I graphed was 0, 2, but it also has 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, something 2, something 2. Y is always 2. Y equals 2 is a horizontal line. If I look at the next one, -4 for x. So here's the x value of -4. There's the x-intercept. And now x equals as a vertical line, which means the slope is undefined. So here's what it looks like. So I draw the slope as being undefined, and I draw that as a vertical line. But once again, think about those ordered pairs. I had -4, 0. I also have -4, 1, -4, 2, -4, 3, -4, 4. Every ordered pair on that line is -4, comma something. X always equals -4, which is why x equals -4 is a vertical line. Okay? If I gave you something like this, let's complete the xy chart. Ready? For the equation y equals a -3, if I have an x value of -2, well, it looks like you know what? Let's fill in the blank there. Let's put a 0 in there. I must have missed that. If I had an x value of 0, what would the y value be if the equation is y equals -3? Well, it would be y is a -3, because y equals -3 is telling me that y should always equal -3, no matter what x is. So if I had an x value -2, then y would be -3. It's always going to be -3. If x was a 1, y is -3. A 7, y is -3. Y is -3. Y is -3. It's the equation y equals -3. So regardless of what x is, y is going to be a -3. And it's the same thing if I had an x equals equation. Doesn't matter what y is, x will always be 3 in that situation. Okay? And this is how vertical and horizontal lines are formed. Okay? So again, graphing using slope, we find a point that's on the line. If we're in point-slope form, we have to use the opposite of the x and the opposite of the y value that we see there to get our ordered pair. And then we use the pattern of slope to graph the rest of the points. Slope-intercept form, we start with the y-intercept, which is the point that we use, and then we use the slope, the pattern to graph from there, okay? And then vertical and horizontal lines, remember, vertical lines are x equals a number, horizontal lines are y equals a number, and vertical lines, the slope is undefined, horizontal lines, it's 0, okay?